We are at the Center of Bioelectronics and Biosensors of Biodesign Institute at Arizona State University, and we have developed a wearable wireless sensor for exposure assessment. This sensor is meant to be an affordable, accurate and sensitive tool to perform exposure assessment studies. The technology is based on two pieces. One of the pieces is the cell phone, which is the user interface, and the second piece is the detection module, that is the actual module doing the measurement for us. There is a wireless communication between the two pieces, so that once we turn on the detection module, we can instantaneously start the recording of the data in our cell phone, and we can see the data in real time, as well as store it and eventually send it via wireless seamless network. We are going to demonstrate how to use this technology. First of all, we need to turn on the detection module. To turn on the device, we start first with the detection module, and we turn on the detection circuit and the pump by using these two switches. After doing so, you will hear a small sound that is corresponding to the pump. So the pump is already bringing sample into the sensing elements and have started the detection. The second thing we need to do is take the cell phone piece and turn it on. We need to wait for the system to start and Windows Mobile to upload. And after the cell phone starts, there is a message that says STM failure. This is because we don't have a SIM card in this cell phone, so we skip this part by pressing done. Once we are done, we press again this same button to start. Here we have the menu with different options, and we need to access this particular icon called Device Application, which is the application we have generated to access the data from our detection module. So we need just to press Enter to access the first icon on the screen, and we immediately can access the data from the device. So as you see, there is a plot that is being recorded on the screen. This plot represents the sensor's response in real time. The time frame is 1 minute. We have here also options to turn on and off a GPS, but we are not going to do so right now. As Analyze Select option here, we choose one of the options. So we press first Analyze Select, and then we go directly to this first sensor to enable the hydrocarbon detection. There are other possibilities, as you can observe, to assess acids, humidity and temperature, but this is the application of interest right now. So we select hydrocarbons and press Enter to access the hydrocarbon sensor, which is called HC. So we have right now the data assesses from this sensor in real time. And you can see that there is a noise, random noise, that corresponds to the very low noise level of our sensor system. Now we have the detection module and the cell phone turn it on. We are ready to perform the measurements, and we put the device in one pocket and the cell phone in the other pocket, and we can perform real-time assessment of environmental exposure. One important thing to demonstrate for these sensors is the capability to discriminate between toxicants, such as those hydrocarbon derivatives from gasoline, from those molecules regularly present in the environment, for example, perfume. The first thing we are going to do is expose the sensor to a piece of cloth that is impregnated with perfume and demonstrate the detection for this situation. So for this situation, you can observe on the screen of the cell phone the real-time data for the perfume exposure. And in this situation, there is a random noise that corresponds to the baseline of the sensor, and there is no positive detection. So in this case, the perfume is not detected. Now we are going to take a look to the gasoline sample. This is a piece of cloth that contained traces of gasoline, and it was exposed to a gasoline environment. So I'm going to hold it next to the sensor, and we are going to observe what's going on with the sensor response. What we observe here is a positive detection of hydrocarbons coming from the gasoline vapors traces present in the piece of cloth. The positive spikes correspond to the sampling period of 10 seconds that is performed together with the purging period of 50 seconds that allows to reestablish the baseline of the sensor. We have a total of 1 minute frame shown on the plot. We hope you enjoyed the demonstration of our technology. We would like to thank NIH for sponsoring our research at Biodesign Institute at Arizona State University.